energy as of today. But as a farewell, there seems to be one misconception that I keep seeing in a lot of people, and that is that you either have all potential energy or all kinetic energy at any given time, right? My goal is that with this cool guy, this basically this little Desmond, I wrote this program, and Desmond's not even here today. I wrote to make a little Desmond here, and I want you to see, I want you guys to actually make some observations about what little Desmond is experiencing in terms of his energies while he's riding on this little half pipe. All right. By the way, what's this shape called?
V.
No?
V.
All right. So you got little Desmond on the guy, right? So I'm going to put up this little bar graph here, right? And this bar graph shows over here you have your total energy, right? Here you have potential energy. Here you have kinetic energy, right? I'm going to stop this at a few little snapshots, and I want you guys to tell me what you notice.
Potential energy.
Maybe you see a lot of potential energy right there, and very little what? Is it zero though?
No.
How come it's not quite zero? It's still kind of moving up just a little bit, yep. Down here?
There's more kinetic.
More kinetic. What about the potential? It's lower. Why isn't it completely zero? He still has some height, right? There's some height right there, right? Okay, now if I do it here, they're more equal, right? Because you still have a decent amount of kinetic energy from down there, and you got a lot of height, so there's a lot of potential energy, right? So let's do it. And what about this bar graph tells you that conservation of energy must be true? Yes, very good. Thank you, Stephanie. Because the total energy never changes. So basically, the whole process of something rising and falling is this exchange of kinetic and potential energy, right? And the key is not that there's either all of one or all of the other, but the key is that they're constantly changing forms, but the total energy of the system is always staying constant, right? What you guys would expect would happen if I added a little bit of friction? Bar graph on there, right? I turn my friction on. What do you guys expect to happen now?
Go a little slower.
Is it going to go slower? Yeah. Any other predictions? All right, let's see what happens. Look at that thermal energy. It keeps going up, keeps going up. So in other words, you don't just go slower, but you actually end up stopping motion because all your total energy ends up turning into all of thermal energy right here. Is that cool? Mm-hmm. And if I have less friction, what would I expect to happen?
It would slow down a lot slower.
It would slow down slower, right? Exactly. Thank you, Sasha. Boom. So it's still converting all into thermal energy, right? You're losing that energy due to friction, but it's happening slower. And then if I have lots of friction, basically like I'm skating on sandpaper, let's see what happens.
Whoa.
Yeah. Yeah. That's like skating on pebbles, like fruity pebbles, I'd say. Cool? All right. Now you guys know it and you will never forget it. Bye. Okay.